So for 14.2, we did the homework of updating all our functions to support Tabular. And the syntax is something that if you've been using datasets with machine learning functions, is going to be very familiar. And incidentally, is also what this team is being using for Tabular. So the target column for machine learning operations is going to be extracted with the root syntax. So you're going to have your arbitrary function here, your tabular object, and then the column you want to like predict, classify, fit, or whatnot. So let's get into some details here. I chose this time the classic Fish-Osiris dataset. This is a classic machine learning problem. It's a classification problem. You want to predict the species based on these 4 numerical quantities: sepal length, sepal width, petal length, petal width. So as you can see, these are columns with quantities inside. So this is a quantity real, centimeters for all of them. And this is just a string column. So again, if you did this data before, the syntax is exactly the same. If you've not, I think it's going to be easy to learn. You do classify tabular species. So this is what it's doing, is automatically dropping the species column from the tabular, of course, and using this as a target for the classification. We always had automatic feature type discovery in our automated ML functions. So this is inferring that these are like 4 numerical values here. If I had like different column types, it will automatically adjust. So for example, let's do something like a bit different, just for the sake of it live. Let's change classify into predict, and let's predict, which is doing regression, and let's predict I don't know, petal length on this tabular. So it's doing the running the optimization and the hyperparameter optimization. This is a small data set, so it's very fast. And now you see that we get the first column is a nominal column. Unfortunately, the tooltip is a bit small, but this is correctly, handling over the types of tabular. So there's not much you have to do here to update your workflow. Analysis function like classify measurements are working as well. Here I'm doing something just for the sake of expediency, no test string split, but just to show the syntax, you can put your tabular data inside classify measurement, and you get this summary. You can query in all the things, like in this case, confusion metrics for the classifier and stuff like that. So yeah, I mean, this is just updates. You can build new workflows staying directly into the Tabular framework. So you can create your custom pipelines. So here, for example, I take my C function, like a classifier function, and I'm using transform columns to add a new column. And here I'm using a feature of transform columns. If I just did this without these pieces thing here, the new column would end up at the end. And without, so well, this you get this at the end. With this, basically this allows me to specify the context. So I want like species first, and then put prediction in. So this allows me, like, this is a visual thing. This is indexed by name, so it doesn't really matter where it is, but it's nice to see them side by side if I want to compare them visually and see that they're mostly the same, luckily. Now, I'm going to show here a nice use case for column-wise thread. So in general, all our machine learning functions are optimized for vectorized evaluation. Here, I'm using them in a scalar form. So I'm just running the cfunc one row at a time. And here you can see, if I run, instead of this thing, if I run like F1 or F2, one is a normal function and one is using column-wise thread. This is running the classifier on the whole column, and then it's distributing the result across the rows. So here you see that there's significant, a small memory improvement, but significant time improvement in not having to reinstantiate the classifier every row. We can build our own version of the confusion metrics using tabular functions. Here I'm adding to the prediction temporary matching column, which is just a true false Boolean if the species and the prediction are the same. And once I have this, I can use aggregate rows and count correct, which is count true, and wrong, which is count false. I could use Boolean and do the total, but you get the gist here. More interesting, I can use a second argument, or a third argument actually, on aggregate rows. Here I'm using aggregate rows in operator form. This nice thing you can pipe, and I'm doing this so you can see the correct and wrong results by species, and you see that this is essentially like a nice report for what happened class by class. So you see, I mean, these two are the closer classes, so they're more difficult to classify correctly, and this one is quite apart from the others, so you should get 100% classification result. Also, again, this is the training set, so it's kind of an easy problem. But I mean, this is it's very natural to insert your machine learning functions in these workflows. One note on piping: all these functions have operator forms, or almost all of them. So if you are the kind of developer who likes piping operators, you can do this, and then add this, and then add this in whichever direction you prefer, and you get the same result at the end if you prefer to read it this way. This is something that we support with all these operators, and you can also do it with select and other like older functions like select, for example, and then you're going to do something like species is setosa, for example. So yeah, this is, I mean, you can mix match new functions or functions, of course, everything is supported. Unsupervised machine learning has also been updated, showing like some of the less famous functions. For example, you can train a distribution on a tabular. So this is automatically on the full tabular with all the columns, training a multinormal distribution, extracting features from the rows. And once you have this distribution, you can do things like generate synthetic data, like random variate, one rows or multiple rows. Machine learning power visualization has been updated as well. Here we have like feature space plot, which is doing feature extraction, and then dimensionality reduction, blocking this, reducing the dimension of these tabular rows to like 2, so I can actually plot them. I can do this in 3D as well, and just leave it at one more dimension to play with. As you can see, what I was saying before, like one class is very apart from the others. We see even like in an unsupervised way by just compressing the features, while the other two here are much closer. More updates are going to come in the next version. You can use the same syntax that we have here for classify. We'll train the classifier here. To train it, you can use it for our classic fit function, like linear model fit, non-linear model fit, and friends. But we are working on nicer way to bind columns and specify models that should come in the next version.